negative. Then what is the potential difference? Vxy equal to Q by C, that one, or C equal to Q by Vxy. It is having some potential difference. Now what I do is I will join these two plates by a wire, any conducting wire, straight wire or something. This is the wire. Iron wire, let it be. And these are the plates. Now what will happen to them? Go back to electrostatics. Vxy, if they are joined by a wire, what should be the potential of x and y? Should be equal. Then capacitance, if Vxy is 0, Vxy will be 0. They're joined by a wire, no? And conductor must be equipotential. So therefore the capacitance will become infinity, no? The capacitance will become infinity. What do you mean by infinite? Any amount of charge it can store. It is as good as equal to a wire. So this capacitor is equal to a wire. So in place of this xy, what you can replace? In place of xy, you can replace it as just a wire. So what happened capacitor? The capacitor gone, and in place of capacitor, a wire has come. So why you are bringing wire only? What do you mean by wire? So is there any limit for what charge it can pass through a wire? There's nothing, no. Any amount of charge I can pass through this wire. And look at this capacitance got infinite. What do you mean by infinity? It can store any amount of charge. So therefore, if a capacitor is shorted, if a capacitor plates are connected by a conducting wire, I should replace with a short circuit. There's a reason. From here we are bringing the idea. Are you getting the method? Later on next week when we go for dielectric breakdown, no, there the formula itself will tell us the capacitance will become infinity. Here I'm just looking, I'm going to take the help of electrostatics. I'm concluding here. So why only wire, sir? Why not any other thing? Because what is the wire? It can allow infinite charge to pass through it. And what is this capacitor now? Infinite capacitance. What do you mean by that? In any amount of charge it can store, no. Store in the sense, so just it can pass through it. So now you pass a charge, no, it will, the capacitor will permit any amount of charge. So therefore I should replace with a wire. So that's what you are having here. This is a switch. Yeah, somebody, Shrikar, yeah. Any doubt you can, okay, by mistake, no problem. So now first you get the initial charge. So shall we divide charge here? So this should be the charge across all. So this should be Q1 minus Q1, Q2 minus Q2, Q3 minus Q3. So for that we need this drop, no, potential drops. This will be 6 minus V1. What all 6 volt, no, a part of that will, so first we'll calculate V1. What is V1? Potential divider formula, I suggest that one. So 6 farad to, this will become 8 farad effective. So this will be V1 is equal to 6 volt into 8, 2 plus 6, I'll write it for convenient, divided by 4 plus 2 plus 6. So this will be 6 into 8, 4 plus 8, 48 by 12, 4 volt. So then how much, okay, this will do one thing. V1 dash, we'll call it V1 dash. So V2 dash should be equal to how much? 6 minus V1 dash. 2 volts. So now we know potential, we can find out the Q2. So what is the value of Q2? Q2 is equal to V2 dash into 2, 4 coulombs. Q3 equal to V2 dash into 6, This will be 12 coulombs. We got the charges and we know initial energy also. What is the initial energy of circuit? Q1 square by 2C1. This is 4 farad. Q2 equal to 2 into 2. Q3 square equal to 2 into 6. Okay, this is the initial energy of the circuit. Initial energy, write it here. Now, after this, what we have to do is, after closing switch, what will happen to the circuit? What to do with that capacitor 4 farad? I should replace with a wire, simple a wire. No, I'll replace this total circuit by a simple, this one in place of that, here. Then I'll carry on the circuit. So this will be capacitance 2 farad. This is cell 6 volt. So that 2 farad has become short circuit. So leave it that one. It's of nowhere in the picture. Now this 2 farad here, what will be charge? Charges we have found out. So here, let it be Q2. I'll call it minus Q2, Q3 minus Q3. I think they are directly parallel, no? So directly we can tell it. What are the charges? Q2 is equal to 6 into 2, 12 coulombs. Q3 equal to 6 into 6, 36 coulombs. Heat generated in the circuit. That was our question. So what is the final energy of circuit? Will be no the capacitor. So there's no charge there. So Q2 square by 2 into 2. So this is the initial energy. How to get the work done by the cell? For that, whose help we have to take it? What charge has flown through the cell? That is what needed, no? Tell me like here we have a negative plate. This will be more risky for you. Take help of this particular plates. Take help of this particular plates. Minus Q2, minus Q3 is there. Finally, it has become minus Q2, Q3. This one, minus Q2, minus Q3. How much it is? Minus 16 coulomb. Finally, how much it has become? Minus 48 coulomb. So what does it mean? Some charge left or some charge entered? Some charge left from it. So the tracing of the charge will be much easier like this. So here we'll assume some charge here. And now you have to ask question, what happened to the charge Q1? What will happen to charge Q1? Because we didn't bother anything here, no? This charge Q1, what will happen? This charge Q1, as you connect a wire, no? So it will flow like this, finish over. This charge Q1 will not come anywhere here. Then again, after this, redistribution of charge will occur. This is the thing. So don't think that this Q1 will jump here or will it jump here. Nothing, no jumping here. So this plus Q1 will come to here minus Q1. So charge will be 0. Charge must be conserved. We didn't destroy anything anyway. The charge Q1. So plus Q1 will come here, will become 0. Okay, how to trace out Q? So look at the Q should be equal to Q, this one, so minus Q3 for this. Charge left should be equal to minus Q2 I'll write in detail so that you'll not get confused. Okay, substitute all these values. So this earlier charge Q1, Q2, Q1. So this was total, the sum of that, it was here, minus 16 minus Q should be equal to minus 48. Or Q should be equal to 48 minus 16. This should be 32. Whatever the work done by the cell, positive or negative, positive charge left, positive terminal. So work done will be, in fact, positive. So UI plus work done by cell equal to UF plus heat generated. So UI value we know. UI value. This is 8. Q2 square by 4. Q3 square by 12. Work done by cell. Q into, say this is E. Equal to, this will be Q2 square by 4